Bismillahirrahmanirrahim. We continue our discussion on data communications and network. We'll move forward into this discussion from where we have left previously. In previous discussion, we developed our understanding on what data communication is, and we have said that data communication is basically the mechanism how data is transferred between two parties. Then we discussed different elements that form data communication, and we discussed different elements in detail that include sender, receiver, the data that is required to be sent, the communication media, and the protocol that need to be ensured to data communication. We also then discussed different types of data communication that include serial and parallel communications. We discussed both of them in detail in previous lecture. In today, we are going to discuss different modes of data communication. What are different modes of data communication? So we are going to discuss this topic in today's discussion. Let's proceed with the topic. So modes of data communication is our today's discussion topic. Transmission mode means transferring of data between two devices, or the method by which the data is being transmitted. It is also known as the communication mode. Networks are designed to allow communication to happen between individual devices that are connected. Actual data transmission from one location to another takes place over the communication links or communication channels. So in order to ensure data communication or data transfer, there must be having the data communication links or communication channels, or we can also call them communication media. This is also one of the elements we discussed previously for data communication. So communication channel or communication link is a path for electrical transmission between two or more devices. The channel can be a group of wires or some specifically designated part of some radio frequency spectrum. So it can be wired or can be wireless simply. There are four common modes of data transmission we are going to discuss in today's discussion. The first one is the simplex mode. In simplex mode of data communication, the data communication is generally one directional or unidirectional. Data is sent or transmitted just in one direction. So it is also known as unidirectional mode of communication. Only one of the two communicating devices on a link can transmit, while the other can only receive. So there has to be a sender that always sends and the receiver that always receives. Receiver cannot reply back. Simplex mode can use entire capacity of the channel to send data in one direction. For example, keyboard and the traditional monitors. Keyboard can only introduce input while the traditional monitors can only give output. In simplex mode of transmission, the connected devices are either sending devices or they are just receiving devices. They cannot be both at the same time. Best common example is your television set, as it only receives signals from antenna but cannot send data, and it is a unidirectional system. Doorbells are other such examples. The receivers in simplex mode of data communication are not capable to reply back the senders. So here in diagram you can see we have a receiver and a sender. Receiver only receives and it cannot reply back, while sender can send always. Next type of communication is duplex mode. In this type of communication, the information is transmitted in both ways. Data is transmitted in two ways, or we can also call it a bidirectional mode of data communication. Duplex mode is further divided in two types. One type is known as half duplex. In half duplex, the communication between the sender and the receiver occurs in both directions, but only one at a time. So, data is transmitted in both the directions, but one at a time. Sender will send at one time, while receiver will receive at the other time. And then the receiver can reply back while the sender will then receive. Sender and receiver can both send and receive data, but only one is allowed to send at any given time. It is considered a one-way road where a vehicle traveling in the opposite direction of the traffic has to wait till the road is empty before it can pass through. For example, in wireless sets such as walkie-talkies, the speakers at both the ends can speak, but they have to speak one by one. They cannot speak simultaneously. This mode of communication is required in cases where there is no need for communication in both directions at the same time. The entire capacity of the channel or the communication link can be utilized for each direction. Another type of duplex mode of communication is full duplex. In this mode of communication, both the stations are sending and receiving. That means they both can either send or receive simultaneously. So, both the sender and the receiver can send and receive simultaneously. One at a time is not the opinion or the concept here. They can do sending and receiving at the same time or simultaneously. In this mode of communication, the signals are going in one direction, so they share the capacity of the channel or the communicating link with the signals that are going in the other direction. And this sharing can be done in two ways. Either the link must contain two physical separate transmission paths, one for the sending and the other for the receiving. Here, as you can see, either the channels consist of two communicating paths, one for the sending and one for the receiving, or the capacity is divided among the signals traveling in both the directions, or there is a single path and the capacity of that path is divided between the sending and receiving ends. For example, your telephone network in which there is a communication between two persons by a telephone line through which both can talk and listen at the same time. Full duplex performs better than the half duplex, while half duplex performs better than simplex mode of communication. So the best among both of them is the full duplex. Then we have another mode of communication that is known as asynchronous mode of communication. Here data is transmitted irregularly at irregular intervals. Here you can see that data is transmitted at irregular intervals. It must insert a start bit before each data character and a stop bit at its end to inform the receiver where the data character begins and where it ends. So in the diagram you can see the start bit, which is generally a 0 bit, and the stop or ending bit, which is generally a binary 1. So this shows the receiving end when the bits are getting started and when they are getting stopped. The asynchronous mode of communication is used to describe the process where transmitted data is encoded with the start and stop bits, specifying the beginning and ending of every character, as we just discussed in the diagram. These additional starting and ending bits provide the timing or synchronization for the connection by indicating when a complete character has been sent or received. Thus, timing for every character begins with the start and ends with the stop bit. So, both the computers synchronize themselves. When one computer receives the start bit, that means the character or the bit is being sent by the sender. And when it receives a stop bit, that means the sending process has been stopped. When there is a gap appears between the character transmission, the asynchronous line is said to be in a mark state. So here you can see in the diagram, when there is a gap between the transmission, so the mode is now said to be in a mark state, which is also known as idle state. So generally, sequence of ones, here you can see sequence of ones are sent. That means there is no transmission or there is a gap between the transmission. So a consecutive ones show the idle state or the mark state. Mark is actually a binary one or sequence of ones that is sent during the period of inactivity. When this mark state is interrupted by a binary 0, that means the start bit, starting off the bit. That means the character is now being sent, or it is also known as a positive voltage. Then the receiving system knows that data characters are now going to flow. So it is due to this reason that the start bit which precedes the data character is always a space between which is a binary 0, and the stop bit which signals the end of the character, which is always marked by the binary 1 or a marked bit. So start bit is always a 0 bit, here you can see, and the end bit is always a binary 1. In between these two start and ending bits are different characters that are being sent between two parties. So whenever a start bit is encountered, which is always a 0, that shows or that signals the receiver that some data is now being sent by the sender. And whenever it receives a binary 1, that means the data sending has been stopped. But if there is a sequence of ones, that means the data transmission has been paused. I hope you have understood the asynchronous mode of data communication. Fourth and the last mode of communication is known as synchronous mode of communication. Synchronous is used, the word synchronous is used to describe a continuous and consistent timed data transfer. It is a type of data transfer in which continuous stream of data signals is accompanied by timing signals. Those timing signals are generated by the electronic clocks within the electronic devices in order to ensure that the transmitter and the receiver are synchronized with one another. So the important aspect for synchronous mode of communication is that sender and receiver has to communicate in synchronized fashion. For that, they have to synchronize their clocks before sending and receiving data. Data is sent in blocks, which we also call as packets or frames. They are spaced by fixed time intervals. Every packet is spaced by fixed time interval. Synchronous mode of data transmission is used when large amount of data requires to be transferred very quickly from one location to another. Speed of data transfer is attained by sending data in large blocks instead of individual characters, as in the case of asynchronous data transmission. Synchronous transmission synchronizes the transmission speed at both the receiving and sending end of the transmission by using clock signals that are embedded within the component or the electronic device. A continuous stream of data is then sent between two nodes. The blocks of data are grouped and spaced in regular time intervals and are preceded by special characters called sync or synchronous idle characters. Here you can see every block of data is spaced with these special characters known as synchronous characters. Once the sync characters are received by the receiver, which is a remote device, they are decoded and used to synchronize the connection. So, before sending the data, Sender first sends these synchronization bits, in order to inform the receiver that data is about to be sent, so synchronize your clock. When the connection is correctly synchronized, then data transmission begins. Since it does not have start and ending bits associated with the data, as we have seen in the case of asynchronous mode of communication, so data transfer rate is faster as compared to the asynchronous one, though errors may occur as the clocks can easily get out of synchronization. Most of the networking protocols such as Ethernet, SONET and token ring use this mode of data communication. So the benefit it brings is that it is the fastest mode of data communication as compared to the previous other modes. But the issue is that two devices that are sending and receiving data may get out of synchronization very easily. Their clocks may get out of synchronization very easily. So some of the data may be sent earlier while receiver may have to wait some of the data. So errors may result in data transmission if this mode of data transmission is used. As we just discussed, before sending the data, sender first sends the synchronization bits. Here you can see the synchronization bits are first sent before sending the data, in order to inform the receiver the data is about to be sent. So the receiver then synchronizes its clock with the sender. So a connection is first developed between the sender and the receiver. Once the clocks of both sender and receiver are synchronized, only then data is transferred from the sender to the receiver. If small amount of data is sent, it works very fine. If data is too large or large blocks of data are sent, then it may happen that the clocks may get out of synchronization. Generally, the receiver clock may get out of synchronization, which may bring errors in data transmission. Let's have a recap on today's discussion. In today's discussion, we discussed different modes of data communication. Modes means transferring of data between two devices. So what are different communication modes when we want to send data? We discussed 4 different types of data communication modes. First one is the simplex mode that we discussed. In simplex mode of communication, data is always sent in one direction, or simply we can say it is a unidirectional mode of communication. That means only one of the two devices on a link can send data, while the other device can only receive. The receiver may not or cannot reply back to the sender. So majority of the capacity or the entire capacity of the channel is used to send data in one direction. The best example you can use for simplex mode of communication are your keyboards, the traditional computer monitors, your television sets, and the doorbells. Other second mode of communication that we discussed is the duplex mode of communication, which is a bidirectional mode of communication. That means data can be sent and received in both the direction, or both the devices can send and receive data. Duplex mode of communication is further divided in two types. One is half duplex. Here, the communication between the sender and receiver can occur in both directions, but only one at a time. Sender and receiver can both send and receive data, but only one is allowed to send data at any given time. So when sender is sending data, it then cannot receive data. It has to do single task at a time. So it is a sort of one-way road, as you can see. Another type of duplex mode of communication is full duplex. In full duplex mode of communication, both the stations or senders and receivers can transmit and receive data simultaneously. That means they can send and receive data at the same time. The best example for full duplex mode of communication are your telephone lines. If you are speaking on your telephone line, so at the same time you can listen to the other person. So phone line is used for both sending and receiving purposes. Third mode of communication that we discussed was asynchronous mode of communication. Here data is transmitted at irregular intervals. For that, generally a starting bit before every data character and a stop bit at the end of every data character is added in order to inform the receiver where the data is started and where it ends. The term asynchronous is used to describe the process where transmitted data is encoded with the start and stop bits, specifying the starting or beginning and ending of every data character. So data is sent here character by character or bits by bits. These additional bits, the starting bit and ending bit, basically provides the synchronization between two devices to ensure the receiver that a complete character has been received. The fourth mode of communication, the last mode of communication, is the synchronous mode of communication. Synchronous describes a continuous and consistent timed data frames. That means both the sender and receiver must be synchronized when data is being transmitted between them. For that, the sender first sends the synchronization bits to the receiver. Both the sender and receiver have their internal electronic clocks. So once the synchronization bits are sent by the sender, the receiver, after receiving the synchronization bits, synchronize its clock with the sender. That means a formal path, a formal bridge or a formal connection has been developed first between the sender and the receiver. Once the clocks are synchronized, only then data is sent by the sender to the receiver. So synchronous mode of communication is fastest as it sends data in groups. known as blocks, packets or frames, as compared to asynchronous mode of communication where data is sent character by character. So asynchronous is slow mode of data communication, while synchronous mode of communication is considered to be fast. That is all that we discussed in today's discussion. We will discuss or will continue this chapter in further more lectures. I hope the points that we have discussed today must be clear to you. If you have any queries, you can email me. My email address is written here, or you can write me on KCMS. That is all for now. I thank you all.